Okay, so this is your video for 6.2. This is over parallelograms, and it's over the properties of parallelograms that you wrote down on your quad chart. So you'll want to have your quad chart out with those 5 properties, and we're just going to go through all of them and now see, hey, now that we know that these are properties, how can we use them in specific problems? So a quadrilateral, remember the definition from your chart, is a quadrilateral with 2 pair of parallel sides. To write the name of a parallelogram, you get to use this little, parallelogram symbol. This is the only shape you get to use a symbol. So don't try to use symbols for rectangle and square and all the rest of them. Only parallelogram. That's because parallelogram is the longest word, so that's the one we want a symbol for. And if you try to use it for all of them, somebody might not, if you're messy handwriting, somebody might not be able to read the difference between a parallelogram and a rectangle symbol. So we use words for everything else. We get to use a symbol for parallelogram. Remember our conversation back in chapter 4? When you're writing the name of an object, you start in one corner, wherever you want to start, and go around consecutively. Just don't jump around. So I could call this parallelogram BCDA. I could call it parallelogram DCBA. I could call it, most likely we'll call it parallelogram ABCD, just so the letters are in order and everybody's happy. The only thing you can't do is like parallelogram BDCA, because I would be skipping around the parallelogram, and that is not allowed. Okay, so let's look at one of these. First thing you always want to do is, of course, label all of your sides. DE is 74, DG is 31, that's hard to see. And the measure of angle FCD, this whole thing right here, is 42 degrees. So find the measure of CF. Well, CF is an opposite side with DE, and we know that opposite sides of a parallelogram are congruent. So if this is 74, then the opposite side has to be 74. Find the measure of EFC. So EFC is this one right here. So now we're talking about consecutive angles. So if we're talking about consecutive angles, look at your quad chart. Consecutive angles are supplementary. So if this one is 142, then this one must be 138. Okay, and last one, DF. Okay, so now DF is a diagonal. So now we're talking about the diagonals. Well, look at your quad chart. What do you know about diagonals? Well, I know that they bisect each other. So if DG is 31, then so is GF, because they have to be equal. That's what bisect means. So that would mean the whole thing would be 62. So this is very simple. As long as you follow your quad chart and just refer back to it, then you just follow which rules you need and use them as you need them. Same story with example 2, but with algebra. So find YZ. So YZ is this side, so I'm going to use his opposite side. What do I know? I know, look at this symbol I'm going to use. In a parallelogram, opposite, I got pop-ups happening to me here. Opposite sides are congruent. So that means I can set up 6a plus 10 equals 8a minus 4. Now I've taken the geometry out of it. Now it's just an algebraic equation that I can solve. So I have 14 equals 2a, so a is equal to 7. Notice it doesn't say find a, it says find yz. So 8 times 7 minus 4, when I go and plug that in, is 52. So there we go. All right, I'm going to pause here and y'all do B, and then we'll see if we match. Okay, so here's my B. In a parallelogram, see, notice why we don't get to use symbols for everything, because that is a horrible symbol for a parallelogram. In a parallelogram, consecutive angles are supplementary. I know these are consecutive because they're right next to each other. They're not across from each other. So that means I'm going to add them up and set them equal to 180. So that is how I got this algebraic expression. Simplify, simplify, b is equal to 7, and then plug it into what they're asking. They're asking for a measure of angle z. So I plug in 7, and I get that that is 65. Okay, y'all try to check it out too, and let's see if you can do the same thing with diagonals. Okay, so both of these are, this is a parallelogram, therefore the diagonals bisect each other. So for both of these, I'm just going to set each half of the diagonal equal to his other half. So 3w equals w plus 8, therefore w equals 4. So it asked me to find jg. So when I plug that back in, I get 12. Same story for FH. I set the halves of the diagonals equal to each other, and I get Z is equal to 9 halves. This one asked me to find FH, which is the whole thing. So I just said, well, if JH is 2Z, then the whole thing would be 4Z. It would be just the same as if you just found one side and then doubled it. I just doubled it from the beginning. So 4 times 9 halves is 18. Okay, for example 3, they've given me 3 coordinates of a parallelogram and asked me to find the 4th. So what I'm going to do here, what do I know about opposite sides of a parallelogram? Well, I know that they should be parallel and congruent. So all I'm going to do is figure out how did I get from K to L. Then I'm going to repeat that process from J, and that will put me where I need to be. Okay, so let's do that. All right, so from K to L, I went 2 to 6, so I went up, I went up 4, and from -2 to 2, I went over 4. So from J, I'm just going to do the exact same thing. So if I go up 4 over 4, that puts me at 7, -4. And you can either do that from the graph. Oops, I didn't go up 4, I went up 3. You can either do that from the graph, or you can do it just by adding to the coordinates. Either way, it's going to get you the same thing. That in order to make this a parallelogram, that point has to be at 7, -4, so that the opposite sides are parallel and congruent. Oh, look, a proof. Aren't y'all so glad the proofs are back? So I went ahead and filled in my 3 pieces that I always know, given, and your proof statement. So look, we're proving that triangles are congruent. So we're going back to chapter 3, side angle side, 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 that kind of stuff. Right now, the only thing I know I'm doing triangle AEB, this triangle with triangle CED. So there are several different ways that you can do this because I have several different choices, side angle side, 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 side. You can do it in different ways. So if you were thinking something different than myself, you may not be wrong, but we just need to double check. So the first thing I would do is I would say, okay, I know this is a parallelogram, so what do I know about parallelograms? Well, I know that CD has to be congruent to BA because in a parallelogram, opposite sides are congruent. Okay, what else do I know about a parallelogram? Well, I know that the diagonals bisect each other. Well, what does that tell me? Well, when diagonals bisect, it tells me this side is congruent to this side, and this side is congruent to that side. So, I know that BE is congruent to ED at the same time that AE is congruent to EC. So now what do I have? I did these for opposite sides. Now I have side, side, side. Okay? If you wanted to, you could have used this same step for step 3 right here. Instead of using opposite sides are congruent, you could have done vertical angles like we did back in chapter 4. And then you would have used side angle. You would have used side, angle, side instead of side, side, side. But either way, you have step 1, step 3, and step 4 have to be there. You could have swapped out step 2 if you wanted to. All right, last example for this one, another proof. It's along the same lines, but you're not using the angles to prove they're congruent. You're using your properties and things you knew from chapter 1. So let's see how far you can get and then come back and check in. Okay, so this one's a little bit trickier, but if you were to draw on there, the first thing I would do is to draw the angles that you want. I want this, and I want H, and I want M. So maybe you could see, hey, there's a reason they told me that these points are collinear. They want me to connect the line all together. So hopefully if you saw that, you might start thinking alternate interior. What do I need for alternate interior? Well, I need parallel lines cut by a transversal. So I know this is a parallelogram, so what better way to do parallel lines than with a parallelogram? So at first, these are two separate parallelograms. So my first step was to tell that HG was parallel to JN, because this is a parallelogram, and then on the other side, JK was parallel to LM. Then I can use that transitive property to say, okay, I don't need NK anymore. I can go directly to the two outside ones. So HG is parallel to LM. And then I have my parallel lines cut by a transversal, so H and M have to be congruent because they are alternate interior angles. All right, y'all have a good day tomorrow.